This is the X-Zone Broadcast Network, broadcasting worldwide on broadcast affiliates and satellite program providers, including CNN Broadcast Network, Sirius Satellite Network, Star Media, Good News Radio Network, Angel Broadcast Network, Wiki Broadcast Network, and WPBN TV. For more information on the X-Zone Broadcast Network, visit us at www.xzbn.net.
Welcome everyone to Too Good to Be True, and of course thank you to all the listeners. Are you ready for an amazing show about the universe? Before we start getting into details, let's just briefly talk about psychic insight and how we apply it.
We choose a subject, then research it, and based on that research, we determine what we think needs to be explained by creating a series of questions. Then Justina provides psychic insight to answer those questions. At the end of the process, we have psychic insight into a subject. The psychic insight is narrated towards the end of the show. Accepting this psychic insight is a question of individual belief. Now let's go through the disclaimers.
Here are the disclaimers. Neither of us claim to have any expertise in any subjects that we discuss. We relate information we find through research in the psychic insight. We are always delighted to hear from the listeners. The show only lasts an hour. We don't have the time to present exhaustive research on any topic. This means that there will be information that we do miss. We want to provide a basis for the psychic insight. We don't care if a theory turns out too good to be true, as the show name suggests. We are only interested in finding out more of the truth about topics. Spirit can only relate insight that is appropriate for our time in history. Free will cannot be affected. Only comments that are appropriate for our time can be given through the psychic insight. Much of the subject matter in shows will have already been covered again and again in other shows. We want to look into subjects in a new, different way and be thought-provoking. We are not so good with pronouncing names, we apologize. And the last disclaimer is, neither of us have any knowledge or expertise in the field of astrophysics or in related fields. If we state something incorrectly, we apologize in advance.
Thank you, Justina. I didn't choose the subjects of the universe, it was suggested.
Yes, I think that accepting the choice is rather ambitious. You don't really know much about the universe, do you?
No, I don't. I think that mankind has only scratched the surface of what there is to know. I've read a few books by Michio Kaku, though also there have been shows on cable channels describing the universe, with Michio Kaku often appearing. Years ago, there was a groundbreaking television show. There had been nothing like it before.
When was it, and what was the show?
In 1980, a scientist in several fields, Carl Sagan, co-wrote and narrated the television series Cosmos, A Personal Voyage. It covered a wide range of scientific subjects, including the origin of life and the perspective of our place in the universe. The series was watched by 500 million people across the globe. Cosmos means the universe as an orderly, harmonious system.
Television shows and books talk about the known universe. I've always wondered what exists once you get beyond the borders of the universe. Is there an infinite nothingness beyond that?
I've always wondered the same thing. What is out there? How far does it go? And what's beyond anything with matter, such as a solid or gas?
Where do you want to start?
Let's start with galaxies.
What exactly is a galaxy?
From the website NASA Space Place, and I'll quote, "A galaxy is a huge collection of gas, dust, and the stars and their solar systems. A galaxy is held together by gravity. Our galaxy, the Milky Way, also has a supermassive black hole in the middle," unquote.
Supermassive for the black hole means something in astrophysics, doesn't it?
Yes, supermassive means the largest type of black hole in terms of solar mass. One solar mass is equivalent to the mass of the Sun. The mass of the Sun is about 1/3 of a million times that of the Earth. The black hole at the center of the Milky Way has an estimated mass of 4.3 million solar masses, but the value is different from different sources.
So that means that if you could weigh the black hole, it would weigh the same as 4.3 million suns, give or take. How big is the black hole?
Different sources give different values, but the diameter of the black hole is reported as being about the same as the distance between our Earth and the Sun, which is about 93 million miles or 150 million kilometers, or 1 astronomical unit.
If black holes are so big and heavy, why doesn't everything get sucked into them?
The simple answer is that black holes are relatively small and that objects are far enough away not to be affected by them. There is something called an event horizon where, to escape the gravitational pull of the black hole, an object or light has to exceed the speed of light. For a 10 solar mass black hole, the event horizon distance is about 19 miles or about 30 kilometers.
How big is the Milky Way, our galaxy?
The Milky Way is 120,000 to 180,000 light years in diameter. A light year is, of course, the distance it takes to travel for a year at the speed of light, which is almost 6 trillion miles or almost 10 trillion kilometers.
Stating that black holes are relatively small now makes sense. The black hole at the center of the Milky Way is small relative to the size of the entire galaxy. But thinking about mass, how many stars are there in our galaxy?
There are an estimated 100 billion stars in the Milky Way.
These numbers are so large, that is a lot of matter or material. It is difficult to get my head around the numbers. But that leads to the question of how many galaxies are there in the universe?
On the NASA website, an article dated October 13, 2016, states that the latest observations from the Hubble telescope indicate that there is actually 10 times the number of galaxies than originally thought. The NASA website suggests that there are 2,000 billion galaxies.
Well, let's continue talking about the universe after this short break.
This is the X-Zone Broadcast Network, broadcasting worldwide on broadcast affiliates and satellite program providers, including CNN Broadcast Network, Sirius Satellite Network, Star Media, Good News Radio Network, Angel Broadcast Network, Wiki Broadcast Network, and WPBN TV. For more information on the X-Zone Broadcast Network, visit us at www.xzbn.net.
Did you know that when you're on the road with limited data or Wi-Fi, you can still listen to the X-Zone Radio Show with Rob McConnell, The Science of Magic with Gwilda Wiyaka, X-1, Dimension X, Space Patrol, and every minute of the X-Zone Broadcast Network by calling 213-401-0080, courtesy of Audio Now. No smartphone, app, or internet needed. It saves your data plan and it's free if you have unlimited minutes. Call 213-401-0080 to listen on any phone, anytime, anywhere. Remember 213-401-0080 for the best of the paranormal, parapsychology, and sci-fi radio programming anywhere, 24/7, 365.
Welcome back to Too Good to Be True. And before the break, we were talking about the different number of galaxies. And Dad, you were saying that the NASA website suggests that there are 2,000 billion galaxies. That's a really incredible number. I wonder why the universe is so big with everything in terms of billions. That begs the question, how many planets and how many solar systems could support life?
There's something called the Drake equation that estimates the probability of intelligent civilizations existing in the Milky Way galaxy. It is named after Dr. Frank Drake, an astronomer and astrophysicist who has searched for extraterrestrial intelligence.
Probability. I used to hate probability at college. But what does the Drake equation estimate in numbers?
That depends. A lot of different people use the Drake equation to come up with different numbers. One number I've seen is 4,500 intelligent civilizations in the Milky Way, but I think the most important aspect of the Drake equation is that it will predict a number greater than 1. Beyond the Milky Way, mathematically, there must be the probability of extraterrestrial life existing in at least one galaxy out of 2,000 billion galaxies.
How do we know that in other places, planets orbit a sun just like in our solar system?
I'll quote again from the website NASA Space Place. So far, astronomers have found more than 500 solar systems and are discovering new ones every year. Given how many they have found in our own neighborhood of the Milky Way galaxy, scientists estimate that there may be tens of billions of solar systems in our galaxy, perhaps even as many as 100 billion, unquote.
Okay, so solar systems are pretty normal, but how big is the entire universe and how old is it?
The edge of the observable universe is at a distance of 13.8 billion light years. So the diameter of the observable universe is going to be twice 13.8 billion light years. So the universe is 13.8 billion years old, assuming that the Big Bang occurred, assuming also that the universe is expanding at the speed of light.
So what is the Big Bang Theory?
I'm going to have to quote this from the Big Bang Theory website dedicated to science. Quote, according to the standard theory, our universe sprang into existence as a singularity around 13.7 billion years ago. What is a singularity and where does it come from? Well, to be honest, we don't know for sure. Singularities are zones which defy our current understanding of physics. They are thought to exist at the core of black holes. Black holes are areas of intense gravitational pressure. The pressure is thought to be so intense that finite matter is actually squished into infinite density. That's a mathematical concept which truly boggles the mind. These zones of infinite density are called singularities. Our universe is thought to have begun as an infinitesimally small, infinitely hot, infinitely dense something, a singularity. Where did it come from? We don't know. Why did it appear? We don't know, unquote.
So the singularity might have existed at the core of a black hole, but what happened before that to create the singularity? The code stated 13.7 billion years ago, not 13.8 for the Big Bang, but that's still a really long time ago.
That again suggests that expansion from the singularity is occurring at the speed of light.
So a singularity started it all, then it went bang. But you can't hear anything in space, as a space is actually a vacuum.
I think the word bang is there to describe rapid expansion, or inflation as physicists often call it. I'll continue quoting from the Big Bang Theory website, starting with the singularity. After its initial appearance, it apparently inflated, expanded and cooled, going from very, very small and very, very hot to the size and temperature of our current universe. It continues to expand and cool to this day, and we are inside of it. Incredible creatures living on a unique planet circling a beautiful star clustered together with several 100 billion other stars in a galaxy soaring through the cosmos, all of which is inside of an expanding universe that began as an infinitesimal singularity which appeared out of nowhere for reasons unknown. This is the Big Bang Theory, unquote.
So something that is billions of light years in diameter appeared out of almost nothing.
It gets weirder than that. I'll continue quoting from the same website. Another misconception is that we tend to imagine a singularity as a little fireball appearing somewhere in space. According to the many experts, however, space didn't exist prior to the Big Bang. Back in the late 60s and early 70s, when men first walked on the moon, 3 British astrophysicists, Stephen Hawking, George Ellis, and Roger Penrose, turned their attention to the theory of relativity and its implications regarding our notions of time. In 1968 and 1970, they published papers in which they extended Einstein's theory of general relativity to include measurements of time and space. According to their calculations, time and space had a finite beginning that corresponded to the origin of matter and energy. The singularity didn't appear in space, rather, space began inside of the singularity. Prior to the singularity, nothing existed, not space, time, matter, or energy, nothing. So where and in what did the singularity appear, if not in space? We don't know. We don't know where it came from, why it is here, or even where it is. All we really know is that we're inside of it, and at one time it didn't exist, and neither did we, unquote.
We have come across the name of Roger Penrose in one or two previous episodes regarding quantum physics and consciousness. I have not heard of George Ellis, but most people have heard of Stephen Hawking.
George Ellis is interesting. He believes that cosmology, the science of development of the universe, includes philosophy as well as physics.
Going back to that quote, there was possibly no space until it popped out of the singularity. Then an incredible quantity of matter appeared, expanded, and started getting cooler. And what I don't understand is before space was created, was there no such thing as distance before the singularity expanded?
I don't know how nothing could be limited as having no space. Surely nothing would go on forever. But the explanation is getting stranger.
How could things get any stranger?
We have to talk about dark matter. The CERN website provides an explanation. That's CERN, which is CERN, the European Organization for Nuclear Research. Physicists and engineers are probing the fundamental structure of the universe. Here is the quote. Galaxies in our universe seem to be achieving an impossible feat. They are with such speed that gravity generated by their observable matter could not possibly hold them together. They should have torn themselves apart long ago. The same is true of galaxies and clusters, which leads scientists to believe that something we cannot see is at work. They think something we have yet to detect directly is giving the galaxies extra mass, generating the extra gravity they need to stay intact. This strange and unknown matter was called dark matter, since it is not visible, unquote.
So this is invisible matter that must be present to explain how the universe behaves.
Yes, I'll continue quoting from the CERN website. Unlike normal matter, dark matter does not interact with the electromagnetic force. That means it does not absorb, reflect, or emit light, making it extremely hard to spot. In fact, researchers have been able to infer the existence of dark matter only from the gravitational effect it seems to have on visible matter. Dark matter seems to outweigh visible matter roughly 6-to-1, making up about 20% of the universe, unquote. Dark matter is like the glue that holds the universe together, and there's also dark energy.
So that must be energy that is hard to detect, but dark would be a scary word in a science fiction movie.
Yes, but dark matter and dark energy are only called dark because they can't be observed directly, not because there's anything dark in terms of being negative. For a description of dark energy, I will quote again from the CERN website. Dark energy makes up approximately 68% of the universe and appears to be associated with a vacuum in space. It is distributed evenly throughout the universe, not only in space, but also in time. In other words, its effect is not diluted as the universe expands. The even distribution means that dark energy does not have any local gravitational effects, but rather a global effect on the universe as a whole. This leads to a repulsive force which tends to accelerate the expansion of the universe. The rate of expansion and its acceleration can be measured by observations based on the Hubble law. These measurements, together with other scientific data, have confirmed the existence of dark energy and provide an estimate of just how much of this mysterious substance exists, unquote. So dark energy accelerates the expansion of the universe, and with dark matter makes up most of the universe.
So dark energy helps expand the universe, while dark matter helps an object stay together. What is the Hubble law?
This describes the motion of astronomical objects with space expanding due to the Big Bang. Hubble, of course, was the famous astronomer Edwin Hubble. The Hubble telescope is named after him. Hubble discovered that the universe is expanding. That's why he has the law named after him.
So if everything is expanding in accordance with Hubble's law, then the planet Earth should be moving farther away from the sun and from the other planets. Everything should be getting farther apart as the universe expands.
According to the New Scientist website, the Earth and Sun are moving apart at a rate of 6 inches or 15 centimeters per year. But that may be due to the Sun losing mass and having a lower force of gravity, or maybe due to dark matter. Nobody knows. But apparently the solar system stays together due to gravitational forces, even though the universe is expanding.
Going back to the Big Bang from the singularity, then the scientific explanation is that everything in this world, including ourselves, the plants, the animals, all the water and rocks, arose from a single event. But the world is made up of different chemicals and elements. How is all the right stuff available on Earth to support life?
Yes, there's a whole periodic table of chemical elements. I've always wondered if they have different elements in different galaxies.
We don't have unobtainium on Earth. I wonder if something like that exists somewhere else. But how were all the elements made up so we can use them?
Apparently, the Big Bang only provided hydrogen and helium and small amounts of lithium and beryllium. So suns provide most of energy by fusing hydrogen into helium. When the hydrogen in the core of suns runs out, the sun will die. The dying sun will turn into a red giant and manufacture carbon atoms from helium atoms. Bigger stars produce elements like oxygen and heavier elements up to iron. Then the sun explodes in something called a supernova.
So, iron is formed by a dying sun. My car is made out of stardust. Awesome.
Yes, Carl Sagan, who we mentioned before, said that if you wish to make an apple pie from scratch, you first must create the universe. So everything, including my coffee mug and ourselves, is stardust.
An interesting thought to think about is that all the different elements were apparently made from the Big Bang and from dying suns, but they all have their own properties. This goes back to the interesting topic of the atom and how each element is actually organized on the periodic table of elements.
Yeah, I know you could spend hours discussing the periodic table of elements, but let's move on to the subject of the supernova, as we've only got two elements as heavy as iron.
What happens in a supernova?
The dying red sun explodes, large amounts of energy are released, and the heavier elements such as gold are produced and to be sent into space.
So what happens to what's left of the exploding dying sun?
It becomes a neutron star, and then it might turn into a black hole after collapsing under its own force of gravity. A spoonful of a neutron star is thought to weigh about 1 billion tons.
Well, we'll have to continue talking about the universe and some very large numbers about the universe after this short break.
This is the X-Zone Broadcast Network, broadcasting worldwide on broadcast affiliates and satellite program providers, including CNN Broadcast Network, Sirius Satellite Network, Star Media, Good News Radio Network, Angel Broadcast Network, Wiki Broadcast Network, and WPBN TV. For more information on the X-Zone Broadcast Network, visit us at www.xzbn.net.
Welcome back to Too Good to Be True. And before the break, we got back into the subject of black holes. And earlier we started with a black hole at the center of the Milky Way. So if matter is collapsed, what is it?
That's a great question. I'm not sure the answer is known. Classically, an atom is made up of one or more protons with a positive charge, surrounded by spinning electrons with negative charges in an equal number to the number of protons in the nucleus or center of the atom. There will be neutrons, as the name suggests, with no charge in the nucleus that increase the atomic mass. So the electrons whizzing around the nucleus is like a mini solar system, but with charged particles. So in an atom, there is space not taken up by the electrons or the nucleus. But in a black hole, everything has collapsed, having been created from a neutron star. There are no electrons whizzing around the protons and neutrons to make atoms, with atoms presumably having a big size relative to their mass.
Aren't there all sorts of subatomic particles? And now we don't think in terms of particles, we think in terms of strings.
Yes, string theory suggests that particles in physics are actually one-dimensional strings. I found my way to a physics forum, and there seemed to be a lot of disagreement on what strings actually are. but string theory does provide for a theory of gravity consistent with quantum effects. Michio Kaku, who we mentioned earlier, co-founded string theory.
So gravity is what we really don't understand in the universe. So that's why physics needs string theory to explain gravity.
Yes, I think we mentioned gravity on another show about the Earth, and I don't think mankind understands gravity, with theoretical physicists trying to help us get there in understanding what gravity really is.
Yes, all I know is that when you take off in an airplane, you're going to end up coming down to Earth eventually, nicely or not so nicely. But anyway, I think it's time to talk about parallel universes. Physics suggests they exist, right?
Yeah, I read about parallel universes in one of Michio Kaku's books. There are supposed to be 11 dimensions to the universe.
If there are parallel universes or different dimensions, then they would be outside of our universe. So should we be talking about them?
If we call a universe a multiverse, that would include all the universes. Using string theory, there can only be 11 dimensions because 13 or 15 dimensional universes would become unstable and would eventually break down to 11 dimension universes. It seems that multiverses have to have odd numbers of dimensions. The strings are similar to vibrating strings in musical instruments. The strings vibrate at different frequencies, resonating through all 11 dimensions.
The number 11 crops up again, doesn't it?
Yes, there's an article from the New York Times dated June the 13th this year entitled "The Human Brain Sees the World as an 11-Dimension Multiverse." Apparently, Swiss and other researchers claim, with the help of computer simulations, that the brain works in up to 11 dimensions.
That seems to be a strange coincidence. 11 dimensions in the brain and 11 dimensions in the universe.
Apparently, when talking about the brain, the 11 dimensions are abstract mathematical spaces, not other physical realms.
Okay, so the brain is not quite like a multiverse, but can you explain more about multiverses?
Yes, the following is from the website dummies.com. In string theory, the multiverse is a theory in which our universe is not the only one. Many universes exist parallel to each other. These distinct universes within the multiverse theory are called parallel universes. A variety of different theories lend themselves to a multiverse viewpoint. In some theories, there are copies of you sitting right here, right now, reading this in other universes and other copies of you that are doing other things in other universes. Other theories contain parallel universes that are so radically different from our own that they follow entirely different fundamental laws of physics, like collapsing or expanding so quickly that life never develops. Not all physicists really believe that these universes exist. Even Pure believed that it would even be possible to contact these parallel universes, likely not even in the entire span of our universe's history. Others believe the quantum physics adage that if it's possible, it's bound to happen somewhere in some time, meaning it may be inevitable that quantum effects allow contact between parallel universes, unquote.
Is there any evidence for multiverses, or is it all theory with a bunch of math?
I found an unlikely source to answer the question. The London Daily Express recently published an article on August the 7th of this year entitled "Our Universe is Bruised at the Edges Where It Collides with Other Universes, Say Boffins."
You are going to tell us what a boffin is, I hope.
Yeah, for 2017, I thought the use of the word was rather outdated. A boffin is a scientist or other technical expert, usually involved in a subject that no normal person would have a clue about. I think it originated in World War II, but it definitely originated in the British Isles.
So what about the bruising?
Here's one quote from the article. In 2010, Stephen Feeney at University College London and colleagues announced that they had discovered patterns in the map of the cosmic microwave background, the leftover radiation from the Big Bang, that suggested that our universe had been left bruised by colliding with other universes. In fact, the team found 4 bruises, implying that our universe had collided with another several times in the past, unquote. Here's another quote from the same article about a region in space that is talked about quite a lot. Experts hoped that they had solid evidence of this long-standing theory after finding a cold spot in the deep universe. The cold spot was discovered in 2015 and is a 1.8 billion light-year wide area where there are an estimated 10,000 galaxies missing. The mysterious area contains 20% less matter than it should, according to the Standard Model, which left scientists baffled. Experts from Durham University said in a paper that as a parallel universe crashed into ours, much of the galaxies and other matter were shoved away from the cold spot. Professor Tom Shanks in Durham University Center for Extragalactic Astronomy said, "Our explanation for the cold spot is that it might be the remnant signal of the collision of our universe and one of the trillions of others," unquote.
One point we haven't covered is the shape of the universe, or multiverse. The Big Bang Theory would suggest it's an expanding sphere, but it can't be that simple.
Apparently, the shape of the universe depends on its critical density, which depends on how fast the universe is expanding. The universe may be closed and curved like a sphere, or it may be curved like a saddle, or it could extend forever with a shape like a flat piece of paper. These different possibilities arise from Einstein's theory of general relativity proposed in 1915.
Another thing we haven't mentioned is wormholes. These are often mentioned in science fiction, where you can find a shortcut to quickly travel vast distances in a short time.
Yes, here is a quote from space.com. "A wormhole is a theoretical passage through space-time that could create shortcuts for long journeys across the universe. Wormholes are predicted by the theory of general relativity, but be wary. Wormholes bring with them the dangers of sudden collapse, high radiation, and dangerous contact with exotic matter," unquote. Again, that was Einstein's theory of general relativity that was referred to.
I guess I have to mention that in a previous episode, that the psychic insight was that the planet does have consciousness. I wonder if the universe itself has consciousness, or does every planet, sun, moon, or asteroid have its own consciousness?
Yes, I think it's time for the psychic insight. I will ask the first question. Is our understanding correct that the Milky Way is a galaxy made up of something like 100 billion stars with a supermassive black hole in the center of it?
There is more to the galaxy than just that, but yes, that information is true.
Is our understanding of black holes correct in that matter has collapsed and become incredibly dense?
In terms of matter, yes.
Are black holes formed from neutron stars?
Yes and no. So the problem with black holes is that science is not advanced enough to explain all the different physics and how exactly a black hole functions. So the hard thing with black holes is that a person obviously can't go visit it and know exactly how it functions. So for now, that is the simple understanding.
Do black holes have event horizons?
Yes.
Is the Milky Way 120,000 to 180,000 light years in diameter?
It's slightly larger, but that's a pretty accurate estimate, yes.
Is distance like time a man-made construct?
Basically, yes. So if you have to think about the original measurements, they are based on basically things that people had in front of them, such as body parts. So yes, distance is basically a human construct that people can put some number onto distances. So just like most of mathematics and numbers, it is a human construct.
Are there 2,000 billion galaxies in the universe?
There's actually more.
Does the Drake equation realistically predict the probability of other life existing in the Milky Way?
Yes and no. So again, that's basically a human construct. And life in general, as most people know, is very unpredictable. So let's just say that life in the universe could be very unpredictable and surprising.
Is it realistic to find another planet in the universe that is sufficiently Earth-like if the Earth becomes uninhabitable?
So yes, there would be a probability, but the issue would be having the technology to get to such a planet. So it'd be hard if something happened to this planet to be able to actually get the people that are still living to the other planet, since the planets are very far away from each other.
In other parts of the universe, do planets orbit suns as occurs in our solar system?
Yes.
Is the edge of the observable universe 13.7 or 13.8 billion light years away?
Yes, and again, light years is a human construct.
Is the universe older than 13.7 or 13.8 billion years?
So basically, the universe always existed in a way, so there's not really a time that could be put on it. But for what exists now, and basically the planets and everything now, that's a good estimate, but of course a rough estimate.
What is beyond the edges of the universe? Nothing?
Basically, it's not nothing. It's more of an endless plane. So this is a very hard concept, since humans think in terms of matter and something being present differently than what energy is. So if you think of terms of energy, it is endless energy.
Is the Big Bang Theory correct that something came out of nothing at a singularity?
There is a little bit more to it than that, but yes, that's a more simple explanation.
Was space inside the singularity?
Yes.
If everything was inside the singularity, what was outside the singularity? Nothing at all?
There is energy inside it and around it. So again, this goes to the hard concept of energy and what energy really is.
If space is mostly a vacuum, what is the difference between space and a vacuum?
So basically, the thing is, again, one, the different terms that are used are all made up by humans. So when you think of a vacuum, you think of nothing existing. Generally, if you are thinking of a vacuum in terms of science. Or obviously, you can think of terms of a vacuum, such as one you clean your house with. But in terms of space, space is really not sucking everything up, but is containing everything. So you can think of space as kind of an energy that is containing everything as inside of it.
I think we need to go to a break now, Justina.
Yes, after this break, we'll continue with the questions and getting more psychic insight about the universe.
This is the X-Zone Broadcast Network, broadcasting worldwide on broadcast affiliates and satellite program providers, including CNN Broadcast Network, Sirius Satellite Network, Star Media, Good News Radio Network, Angel Broadcast Network, Wiki Broadcast Network, and WPBN TV. For more information on the X-Zone Broadcast Network, visit us at www.xzbn.net.
Did you know that when you're on the road with limited data or Wi-Fi, you can still listen to the X-Zone Radio Show with Rob McConnell, The Science of Magic with Gwilda Wiyaka, X-1, Dimension X, Space Patrol, and every minute of the X-Zone Broadcast Network by calling 213-401-0080, courtesy of Audio Now. No smartphone, app, or internet needed. It saves your data plan and it's free if you have unlimited minutes. Call 213-401-0080 to listen on any phone, anytime, anywhere. Remember 213-401-0080 for the best of the paranormal, parapsychology, and sci-fi radio programming anywhere, 24/7, 365.
Welcome back to Too Good to Be True. And before the break, we are going through the questions and answering the psychic insight about the universe. So, Dad, can you please continue on with the questions?
Yes. Is George Ellis correct in thinking that the study of the universe is about philosophy as well as physics?
Yes, there's a lot of philosophy in it, also spirituality.
Is there such a thing as dark matter?
Yes.
Does dark energy exist?
Yes.
Is the universe expanded, aided by dark energy?
Yes and no. It's not only dark energy, but energy in general. So this goes back to the whole concept of energy and the endlessness of it.
Does dark matter help objects stay together in galaxies and as galaxies?
So again, the concept of dark matter and labeling it that is what humans call it. But yes, there's energy that keeps things together.
Einstein said that matter is energy. So are energy and matter the same?
Yes.
Why is the Earth and the Sun moving apart at a rate of 6 inches or 15 centimeters per year?
Basically, it is the normal shift of planets. So this happens a lot of the time where the planets slowly shift, since obviously Earth is a huge object with its own energy, and basically the sun has its own energy too. So there's always going to be energy interference in a way, and there's always going to be a small shift. So it's really nothing to worry about since this is the normal cycle.
Do different chemical elements to those on Earth exist elsewhere in the Milky Way or in other galaxies?
Yes.
Were heavier chemical elements formed in dying suns?
So you can think of it as basically a dying energy. So yes, one main source is from dying suns.
Is the model of the atom like a mini solar system consisting of electrons, protons, and neutrons correct?
Yes, but there's going to be more discoveries about how the different elements of atoms actually interact. So just like most things in science, there's more to be discovered.
Is there any reality behind string theory?
Yes.
With strings having one dimension and vibrating, are they more about energy than matter?
So everything really has its own energy. So yes, you can think in terms of energy, but again, energy and matter can be very, very similar. So the simple explanation would be yes, energy.
Gravity seems to be key in understanding the universe. Why is gravity so difficult to understand?
Because it is not something that someone can hold. So if someone could hold gravity, such as they could hold a shoebox, then humans would be able to wrap their minds around it. But the whole concept of energy, gravity, forces in general, is still a subject that needs more exploration, since humans like to think of what's in front of them physically instead of what's not. So there is something like gravity is something so widely accepted is because people can feel it, but it's not so widely understood since people can't hold it.
Do we live in a multiverse with 11 different dimensions?
So yes, there's multiple different dimensions, but there's not exactly 11.
Is there a connection between the discovery that the human brain could work in up to 11 dimensions and there may be 11 dimensions in the multiverse?
So there is, you could say, 11 dimensions, but the dimensions basically shift. So at one time, not all 11 might be present, if that makes sense. So multi-dimensions could be its own show, basically, since it's very complicated.
But is there a connection between the human brain and the multiverse?
Yes and no. So let's just say that the brain functions in a way that it's aware of the different dimensions, but cannot physically see them.
What are the different dimensions like in the multiverse?
So basically, they each have small shifts. So it's almost like the different paths unraveling, but they all lead to the same endpoint. So you can think of it almost as clones, but the clones are doing almost the same thing at the exact same time, but it all leads to the same endpoint.
Is there another version of me doing much the same in a different dimension?
If your soul chose that when you came down, then yes.
Is there any truth in universes colliding and getting bruised?
Yes.
Is a cold spot in deep space evidence of a multiverse?
Yes.
What is the shape of the universe? Is it like a sphere, like a saddle, or flat like a piece of paper?
Flat.
Does the universe have consciousness?
Yes.
Are there wormholes in space that provide shorter distances between points?
Yes.
What does mankind misunderstand most about the universe?
Basically, the misunderstanding comes when humans can't imagine the relative size of the universe and can't really imagine life outside of their own planet. So the misunderstanding comes when scientists can basically see other planets or do different discoveries. But the problem is that the technology is not advanced enough to actually go get the physical evidence. So just as stated before, it's hard to conceptualize something when it's not physically right in front of you. And obviously, humans can't just reach up and touch the entire universe. So the concept seems very larger than they are.
Have scientists on Earth done a wonderful job in helping mankind understand the universe?
Yes, and it's important for future scientists to keep studying, since even things like the molecules and atoms can be studied more in depth, or even small things like different planets and discoveries on those planets can be studied. So that is why science is so important, because it doesn't only find new discoveries, it also pushes the limits of the human mind.
That's the end of the psychic insight. So I have to ask the question, is the universe as described by science and by the psychic insight too good to be true?
That depends on what you are prepared to believe.
I think I have to clarify one point. The psychic insight at the end suggested that discovering a planet is a small thing. I think that these types of discoveries are happening all the time. But understanding what is inside an atom, such as at CERN with the Giant Hadron Collider, is what is going to help unlock the universe.
Yes, that was a lot to take in, especially if you're not a physicist. But we are always open to suggestions for new shows. We have a couple of ideas in the works, I know, but it's more fun getting suggestions.
This was more than interesting. And to all the physicists out there, we're not physicists, but science is a key for us to all have a future in which we really understand the universe or multiverse we live in.
Yes, but philosophy and spirituality were also mentioned. Albert Einstein said that imagination is more important than knowledge. So it sounds like all sorts of abilities are needed to move mankind forward.
Yes, I got another disclaimer. I skipped from classical, I think it's Bohr theory, I don't know. We got electrons, protons, neutrons, and then jumped to strings. And I avoided all the subatomic particles and that whole subject matter. So that was kind of deliberate. We could only do so much in an hour, and I wasn't going to suggest that that science didn't exist or it wasn't important. It was just that I think in my simple mind, it was just simpler to skip from the simple model of the atom to string theory as co-founded by Michio Kaku.
Well, and I think the most interesting point that we kind of discussed before and discussed a little bit in the show is the periodic table of elements. So as you know, I would talk about it for a whole hour if I could, but I think it's really interesting just even thinking about all the elements around us and how all these different elements have their own properties, and then we use those for human life. So we were talking about like a coffee mug or a car or things like that. It's interesting to think about the atoms and how those make up the elements, and then that makes up basically every human need. So I think that goes kind of into the spirituality and philosophy is with the Big Bang Theory and everything that happened, how did Earth actually become something that could actually support life?
Yes, and having read a few books by Michio Kaku and other people, there seems to be a guiding hand. That's what they seem to be saying. So I guess the psychic insight said spirituality was important. So I think science is going to help us. It's going to expand our mind, but there's also the spiritual side as well, and also the philosophy that was talked about.
Well, I think it's a good time to mention our Facebook page. So as always, I want to mention it that we do have a Facebook page that's called Too Good to Be True, and the first two is spelled TWO. And we would love if you go there, follow us, like us, and bring up any new suggestions. So this was actually a show that was suggested for us, and it's kind of fun taking those suggestions and running with those.
Yes, I hope we don't have suggestions that are on tougher subjects in the universe, because that was a lot of information in a short time, and I hope it all made sense.
Well, and I do not want to do any suggestions of quantum mechanics. I think keeping it simple is enough, since neither of us are quantum physicists or experts in quantum mechanics. And I think that's the hardest part for us, is that some of this information is so complicated that it takes people years and years and years to actually understand the concepts. So we try to keep things pretty simple in the shows, since one, we're not experts on it, and two, we could talk for hours and hours just about one topic or one piece of the show.
Yes, I think we'll put a definite ban on quantum physics, because that's just beyond me and most people, I believe. But again, we would really welcome some suggestions for subjects for shows upcoming.
Well, and I think any suggestions we're open to. So if you want to hear about any unexplained mysteries, any strange landmarks, even pieces of the show. So if you want to have a show about maybe life on other planets, anything like that, we're completely open to suggestions.
Or ancient monuments.
Yes, of ancient monuments. But of course, thank you to all our listeners, and we really appreciate you guys listening to our show.